Welcome. This is our Research 101 faculty video series screencast about quantitative and qualitative data. A brief overview about the similarities and differences between these two research techniques. I'm Eric Landrum from the Department of Psychology.
And I'm Pat Pike from the STEM Station. Eric, faculty in STEM fields, that's science, technology, engineering, and math, often have questions if they're interested in education research about what kind of data they can collect.
And I think what this screencast will do, it'll provide just a brief overview about, again, the similarities and differences. And at the end of the screencast, we'll provide a list of references if faculty want to do a deeper dive.
Great, let's get started.
All right, very good. And so we've got an overview of two different types of data, and we can kind of give a brief comparison here between qualitative and quantitative approaches. And you can see this on your screen, obviously, as we're talking. The qualitative data tend to be verbal or non-numerical, and really qualitative researchers are mostly interested in discovering patterns. For quantitative data, they tend to be numerical, that is nonverbal, and typically you're doing hypothesis testing or you're testing for a theory or a belief or an attribution of some sort. And so it's really about describing and testing with quantitative data. And so that's kind of a rough distinction. Qualitative data depends on verbal or word responses. Quantitative data depends on numerical or number-based responses.
So I take it you're going to tell us which situations are most applicable to which kind of data?
Well, sort of. I think there are research situations where both types of data are very appropriate. And to be honest with you, a lot of this depends on the training of the researcher. So I was trained as a hardcore quantitative researcher, so I kind of look at the world through that lens. Others are trained as a qualitative researcher, and that's the way they look at the world. And so I think it's best to know about both types and then to do kind of like a mix and match, and maybe make sure that you fit the data to the situation. So that's kind of the goal. So here's a kind of a long-winded example that people can read because they don't want to hear us read this, right? I mean, it'd be kind of boring. But you can kind of see it's a STEM effectiveness example where a researcher might have asked people on a scale of 1 equals strongly disagree to 5 equals strongly agree. That's an agreement scale. That's very typical in social sciences and education research. But also at the end of this example, they asked people to fill in two open-ended items. The first one, how do you think about information? And then the second one, what suggestions do you have for STEM student recruitment?
Now, is this example considered quantitative data or qualitative data?
That's a great question. And actually built into this would be both. And so the 1 to 5, so if I'm giving it a 4, that means agree. That we're going to call that quantitative data. And what you type into the box, if you're on Qualtrics or some sort of Google form, the words that you type into the box will be the qualitative data. And both can be very valuable and provide insights that are important to researchers. So, and here you can just see a really quick little table from Mertler and Charles. And this is out of an educational psychology textbook. And again, all the references are at the end of this presentation. So you can see that there are branching paths here for qualitative versus qualitative, but you're going to end up in both cases with research findings which are summarizing the results of the data analysis. So there's different techniques, different software programs, and we're going to briefly highlight those during this screencast. Again, here's just another really quick way to differentiate between qualitative versus quantitative. Qualitative is talking about the quality of the data, descriptions. Quantitative data, the quantity or the amount or the magnitude. So just to kind of pound that in there and make it as clear as possible.
Eric, for scientists, thinking about words as data sounds like it might be sort of messy and maybe even a little unscientific.
Well, for scientists, social scientists, and everyone, you're exactly right. Words are messy. They're hard to analyze, which is why a lot of people like me favor or tend to favor a quantitative approach. I can manipulate numbers in an Excel file or SPSS pretty easily, but words are much more complicated to analyze. And you can actually do a qualitative analysis that turns those qualities into quantities, which is what some qualitative researchers do. But you can see from the quote on the screen here, it's small wonder then that most researchers prefer working with numbers. I mean, it's just messy. However, sometimes the richest data comes from qualitative data. I might be able to tell you the mean on that 5-point scale is a 4.23, but if you read a direct quote in someone's own words, that can be very persuasive. And a lot of different STEM researchers are trying to affect policy. And so you might want to have the quantitative data as well as that qualitative persuasive data to affect policy change, to encourage students to pursue STEM disciplines. There's lots of good uses for quantitative as well as qualitative data.
Well, let's take a look at both then. Let's look at some, can you give us some quantitative and qualitative examples?
Absolutely. Just a really brief overview, and we'll start with quantitative here first. And so you can see a couple of definitions that we provide on the screen. We're talking about a numerical data collection approach. Quantitative variables vary in amount or quantity, magnitude, amplitude, however you want to talk about that. And you can see here, and I'm going to use my mouse here on this little indented example. Here would be the classic survey where from 0 to 10 or from 1 to 5, and we're asking people to take their impressions or behaviors or beliefs and translate them into a quantitative scale. And so that's a classic thing in the social sciences, and I think it's going to be an important tool for STEM education researchers as well. Just really briefly, there are multiple statistical data analysis options, quantitative data. For example, our campus has an SPSS site license. You get Excel. R is an open source free software. SAS and Minitab are available in different places on campus. I'm not quite sure if they're open source or site license or not, to be honest. And so, but you can see the websites there if you want more information, and you can always check out OIT in our local website to see what software is available.
Many scientists and engineers are very familiar with Excel.
Okay.
If they wanted to learn another package, where would you recommend they start, or which one of these programs might be most intuitive to their previous experience?
Wow, that's an amazingly good question, and my gentle answer would be none of them are intuitive. I mean, so if you're an Excel user, you'll like SPSS because it's rows and columns, but it may not be this. It won't be the same experience. And so, for example, if you wanted to do a t-test in Microsoft Excel, you can do that. You can also do it in SPSS, but SPSS will offer more advanced features beyond the capabilities of most Excel users.
One more nuts and bolts question.
Sure.
If I wanted to start using SPSS, about how long do you think it would take me to get up to speed and be able to use it with enough proficiency?
Gosh, that's a great question. I would say 4 or 5 hours. I mean, you really kind of got to dig into it. It's like any new software package, and it's going to take a while to figure out the nuts and bolts. If you come in understanding what a t-test can do, that will accelerate that because when you read the printout, you'll know, okay, there's my p-value, there's my degrees of freedom. And so that'll be, the more you know about statistics going in, the faster the software learning curve will be, at least in my opinion.
Oh, great. Well, 4 to 5 hours, that sounds doable.
Yeah, it's kind of a geeky weekend, right? You don't want to mow the lawn, you don't want to shovel the driveway. You can sit in front of the computer. SPSS, obviously, there are resources on campus. There are experts, there are webinars. SPSS website is rich, and so it has lots of resources available there.
Sort of sounds like fun.
Yeah, in a geeky scientific way, absolutely. And so, obviously the quantitative approach is going to be number-based, and we generate, scatter plots, we generate bar graphs, they're data-based. The overarching ideas for a quantitative research approach is to strive for validity and reliability. You can see some of the brief definitions there. Reliability means just consistency of measurement. If I ask you something one time, I ask you again without any change in between, I should get roughly the same answer. Validity talks about, are we measuring what we think we're measuring? And there's lots of different types and versions. In fact, it would be another great screencast in this faculty research series to talk about the different types and flavors of reliability and validity.
Okay, that'll be the next one.
Is that really the next one? Okay, well, we can see. We can figure that out. So to switch gears now, so we gave you a brief overview of quantitative data. With regard to qualitative data, again, it's about words. We've already made this clear. It's ambiguous. It has multiple meanings. You can't just do a keyword count sometimes. Sometimes it's called keyword and context, where you have to look at the words before and after the keyword to extract any meaningful analysis from that. Just as there are software packages for quantitative data, as you can see here on the screen, there are software packages for qualitative data. I think in vivo is probably the one I know the most about, and we have some in vivo campus experts here at Boise State. And so there are resources available. Actually, the guy that comes to my mind is Ross Perkins. I know he's done workshops for the CTL about in vivo.
And there's a in vivo users group.
There is.
Yes, there is.
I would actually have to join it.
I'm on their mailing list. So, would you recommend always using a data analysis program to sort through your data, or are there opportunities where you might want to do more manual coding?
Actually, I think the manual coding can be a really good idea if you're just starting out, because you might then be able to see the advantage that the software provides you. I think it's analogous to we make kids do long division first with paper and pencil, but then we'll give them a calculator which will accelerate, what they can deduce. I think it's the same thing. And so, I mean, you could do this with note cards and stacks and piles and kind of, do content analysis and look for patterns, or you can have the software help you do that. Of course, it's always as good as the operator, and so it's the human researcher that has to determine whether the software output makes any sense, and that's for both quantitative and qualitative research.
Okay, well, let's look at the kind of things that people say when you ask them questions.
Absolutely. So here's a classic example from the literature, and so a company or a organization, or it might even be an initiative on campus, like an REU type of initiative. You might ask a question like, so what are some of the specific problems needing action in the organization? And you can pause, obviously, look at the screen and make it bigger, but you can see, participants might type into a box on a Qualtrics survey a bunch of things just like this. Well, I think there's like 30 or 31 responses there, and that might be insightful. You might pull some quotes for a newsletter or for an NSF grant proposal. You might have some quotes in there, but that's raw data for a qualitative researcher. And so by using some sort of analysis technique, you might actually end up with data like this after content analysis. So those 30 some odd comments are now summarized into 6 themes. And so the 6 themes then become much more manageable in our heads as concepts than remembering 30 individual comments. And that's really the benefit of a content analysis or a factor analysis. We're reducing a large number of ideas to a smaller number of ideas, which makes sense. And so, again, you might not be able to see these on the screen, but here are the 6 themes, what are labeled here inductive categories. And on this next slide, we've actually got them repeated again for you. So rather than remembering those 30 items, you can see these 6 themes.
And the input seems much more nuanced than just the 0 is a bad experience or 10 is a great experience.
It's much more nuanced because we're again, the data format are words, and so you can really get it. I mean, we could have done this with a quantitative approach, but the data are going to look different, and they're going to have different applications, and I think a different level of persuasiveness to external audiences, which you might be interested in, either for affecting policy or for a grant proposal.
So you really need to begin with your end in mind, your research question in mind.
Always. You always design backwards. And so you think about, what do I want to be able to say when the study is done? And then you figure out this method. We're using both quantitative and qualitative techniques together. So just as validity and reliability are key for quantitative researchers, qualitative researchers kind of translate that differently. And these are the 4 key ones that are classic from qualitative research: credibility, transferability, dependability, and confirmability. And so, to be quite honest with you, these overlap nicely if we were to dig in deeper into what we mentioned earlier regarding reliability versus validity. So these are just some of the criteria that they strive to achieve. I think that's it. We promised you some references at the beginning of this screencast. They're there. You can obviously go backwards and after this next slide if you want to look at them deeper. But this has been a production of the STEM Station here at Boise State.
And we hope this helps you get started in your research.
Yeah, you can see our email addresses on the bottom of the screen there. Email us and let us know if this was helpful. You could tell us about what future topics that might be most helpful to you as you pursue your STEM research needs.
Thanks, Eric. This was fun in that geeky sort of way.
It was kind of fun, Pat. Always a pleasure.